This is our AB Calculus test, second 6 weeks, 2017. This test is a smattering of things we've learned so far this year. So it's not going to cover everything, but it's going to be pretty representative of the major things. Problem 1, if h of x equals 3 square root of x, what is h prime of x? Well, the first thing I'm going to do this is have a rewrite. So I'm going to take this h of x, and instead of writing it in the radical form, I'm going to write it in rational form, which is going to be 3x to the 1/2 power. And then now we're going to change this to h prime of x. Now you got to put h prime of x or something, the derivative. H prime of x is the easiest way to write this. So you take this 1/2 out front and multiply this by 3, and then you're going to have x to the 1/2 minus 1, or negative 1/2 power. So that's going to simplify to h prime of x equals, we have 3, and we have 3 over 2, so 2 will go down here, and x to the 1/2, negative 1/2 we can write as square root of x here in the denominator. So that's going to be our answer to problem 1. Problem 2, for the function g of x equals sine x plus 2 cosine x, what is g prime of pi over 2? For this one, we have two terms separated by a plus sign, and so we're going to be ready to differentiate this. So we're going to write this as g prime of x is equal to, the derivative of sine is cosine, so we have cosine x, and the derivative of cosine is going to be negative sine x. We're going to have, instead of be negative 2 sine x. And now we're going to have g prime of pi over 2 is equal to cosine pi over 2 minus 2 sine pi over 2. My pen seems a little bit glitchy today. I don't know what it is, but I'm trying to be legible. So just if we know what cosine pi over 2 is and sine pi over 2, what that's going to look like, if we go back to our you can circle trigonometry, pi over 2 is going to be up here. And the coordinate pair associated with that is going to be this one here, which is point 0, 1. So your cosine is your 0, right? That's going to be cosine pi over 2. And 1 is going to be your sine pi over 2. So that's going to be g prime pi over 2 is going to be equal to cosine pi over 2 is 0 minus 2, and sine pi over 2 is 1. So summary statement, g prime pi over 2 is equal to negative 2. So that's our answer in work shown for problem 2. 3, for the function h of x equals x squared, find the point of the graph of h of x where the slope of the line tangent to the graph of h of x equals 4. Well, to find the slope, we usually we'll take the derivative of this, so we'll say that if h of x is x squared, h prime of x is going to be 2x. And if we want to find the point, we need to substitute in this 4 for h prime of x. So we go down here and put in 4 equals 2x. And if we divide by 2, we have x equals 2. And so our point That's what we're being asked, right? Point is going to be this 2, comma, and then we go back to the original function to find the y-coordinate. So h of 2 equals x squared, or 2 squared, which equals 4. So our point is the coordinate pair 2, 4. So that's our correct answer, 4. Problem 3, and at that point is where the slope of the line tangent to the graph of that quadratic function is 4. 4, find the equation of the line tangent to the graph function f of x equals x over x minus 1, where x equals 2. Well, to find a tangent line, we need to have 2 components. We need to have a point. Well, your point, your x-coordinate, is already identified as 2. And to find the y-coordinate, we're going to find f of 2. So we're going to have 2 over 2 minus 1. So that's going to be 2 over 1 equals 2. So our point here is 2, 2. And now we need to find f prime of x to find the slope at that point. So what we have here is we have a quotient of 2 functions. So we have a high component here, which is going to be x. The derivative of the high is the derivative of x, which is 1. We have the low is equal to x minus 1, and the derivative of the low is equal to the derivative of x minus 1, which is 1. So f prime of x is equal to low, which is x minus 1, times the derivative of the high, which is 1, minus high, and high is x, times the derivative of low, which is 1, all over low squared, and low is x minus 1, quantity squared. So we can just substitute in at this point if we want to. But I'll just simplify further. We're going to have the numerator x minus 1 minus x over this 20x minus 1 squared. That's going to be f prime of x. And the last thing we're going to do is plug in 2 for that, so f prime of 2, which will give us our slope for our tangent line. Okay, I forgot to cross out x minus x in the numerator up here. So we're going to get negative 1 over 2 minus 1 squared. So that's going to be negative 1 over 1, which equals negative 1. So our slope, m sub t, equals negative 1. So our equation is going to be y minus y1, which is 2, equals m, which is negative 1, times x minus x1. So that's going to be our answer right there, slope of negative 1. Okay, 5. A water holding tank has been cleared of algae, but it tends to grow back quickly. The amount of algae in the tank at the time between t, 0 and 5, is given by differential function a, where t is measured in days. The amount of algae a sub t is measured in pounds, is recorded once a day and is shown in the table above. Use the data table to approximate. Okay, when you see approximate, okay, there's going to be one of two things. Okay, it's going to be average rate of change, right? Or in integral calculus, it's going to be some kind of estimate of some kind of integral, and for that you would use some kind of Riemann sum, right? And so you just have to look at this And you have to say, well, what kind of approximation is this? Well, A prime you find by taking an average of A. Okay? An estimation of A prime would be the average of the change of the slope in A. And so 3.5 is right here between 3 and 4. So your average, okay, we can say estimate. Let me just write it out a little better. Estimate or approximation of A prime of 3.5. What you do is you take on either side. So you take this, we'll say this is B here, 4 is B, 3 is A. So we have 14.3 minus 9.7 over 4 minus 3. And we can just leave it like that. And it says include units of measure. Well, that's going to be pounds, which I'll make a Latin abbreviation of LBS, per day. And that's it. And then, yeah, you can make this, I think it's going to be 4.6 pounds per day. That's it. You need to have the units of measure. Is there a time? By the way, there's nothing about intermediate value theorem in part A. Okay? Is there a time? Is there a time? That's an existence theorem. Is there a time, or must there be a time? Okay, and you can, okay, according to IVT, which is abbreviation for intermediate value theorem, yes, because okay, 2.5 is greater than A sub 0, but is less than A sub 1. And if you can, in other words, say the same thing to identify correctly an answer, that would be correct also. Okay, 6. For what value of k, if any, is the function f(x) equals 2x squared plus 7 for x is less than -1, kx plus 4 when x is greater than or equal to -1, differentiable at x equals -1. So we need to have, for differentiability, we need to find the limit to different things. First of all, we need to test for continuity. To be differentiable, we have to be continuous first, right? So for continuity first, we would write this as the limit as x approaches -1 from the left side of f of x equals the limit as x approaches -1 from the right side of f of x. And so we can just, for clarity's sake, I'll just write the equations without -1 put in. So we have 2x squared plus 7 on the left side. On the right side we have kx plus 4. And then we're going to go ahead and substitute -1. So on the left side we have 2 times -1 squared plus 7 equals, and the derivative of k, and k times -1, k, x is -1, k times -1 plus 4. So we have 2 plus 7 on the left, which is 9, equals -k plus 4, and if we subtract 4, we have negative k equals 5. So multiplying by negative 1, we have k is equal to negative 5. Okay, now for differentiation, we'll have to say this time the limit as x approaches negative 1 of not f of x but f prime of x is equal to limit as x approaches negative 1 from the right side of f prime of x, and we'll just take these derivatives. Derivative of the left side here, this 2x squared plus 7 is going to be 4x. And on the right side, the derivative of kx plus 4 is going to be k. And if we substitute in negative 1 for x, we get 4 times negative 1 equals k. So therefore k is equal to negative 4. And so based on what we have, these two things have to be equal, right? K has to be the same in each instance, but are they the same? No, they're not. You can see if you just chose one separately, for continuity it would be answer choice B. For differentiability section would be answer choice A, but they are not the same. So therefore there is no such value k. D is your correct answer. Okay, 7. Let f(x) equals 3x squared minus 5 for x is less than or equal to 1, 6x plus 2 for x is greater than 1, which is the following are true statements about the function. Okay, limit exists. Well, again, like we did in problem 6, limit as x approaches 1 from the left side of f of x equals limit as x approaches 1 from the right side of f of x, and then we're just going to put in 3x squared minus 5 for left side equals 6x plus 2 for the right side, and just substituting in, we have 3 times 1 squared. We're going to get 3 minus 5. On the right side, we have, let's see, that's going to be 6 plus 2. So we get negative 2 equals 8. Are they correct? No, they're not. So the limit does not exist. Now, and then an answer choice, since there's not continuity, does f prime of 1 exist? You have to have the, that will not exist either because of existence. So 1 and 3 are not correct. So just based on this logic so far, A is the only possibility of right answer we have left. So we'll go ahead and do that last one to be sure. We have a limit as x approaches 1 from the left side, not of f of x, but f prime of x, equals the limit as x approaches 1 from the right side of f prime of x. And we'll just take the derivative of this left side, which 3x squared minus 5 is going to be 6x. And then on the right side, we're going to have 6. Derivative of 6x plus 2 is 6. If we substitute in 1, we get 6 times 1 equals 6. So these are equal to each other, which means that the limit as x approaches 1 of f prime of x does exist and equals 6. So A is our correct answer. Okay, 8. Let f of x equals the limit as h approaches 0 of point x plus h squared minus x squared over h. And so with the definite derivative, it's going to be f prime of x is going to be equal to the limit as h approaches 0 of x plus h. Well, I'm going to just write in the general form here. It's going to be f of x plus h minus f of x over h. And so based on this format, f of x is equal to x squared. Now, it says let f of x equal that. Well, really, f of x is going to be f prime of x, or you can change it to g of x. And so we could say g of x, we're really looking for the first derivative of this. That's what f of x is located here. And so that's a little bit confusing here because they are different things. So f prime of x is going to be 2x. And for f of x to equal 4, if we substitute in 4 equals 2x, we're going to have x equals 2. And again, the confusion is that usually they would call this f prime of x, because this definition derivative is the first derivative of, is this definition derivative thing here. But that is our correct answer for 8. For 9, if f of x equals sine x times x cubed, what is f prime of x? So we have here is two different things, two different functions. We have the product of two functions. We have sine x times x cubed. And to differentiate that, I've had this graphic organizer in my class where we say they have like u prime plus, or uv prime plus vu prime. So we can call sine xu, and the derivative of sine x is cosine x. And then x cubed is over here for v, and v prime would be 3x squared. So f prime of x is going to be 3x squared sine x, and then plus x cubed cosine x. And that's really all there is to it. We could factor out x squared from both of these terms, but we'll just leave it like that. Okay, 10. F of x, the semicircle, is shown with a radius of 4 units. What is the integral from 0 to 8 of f of x dx? And I drew this semicircle not too well on the left side, at least. So we're really looking for this area all here that I'm shading in. And so area of we just have to know the formula for area of a circle. It's going to be pi r squared. And if we have a semicircle, so for area of a semicircle, we have to divide that by 2. So find your area of the circle, divide by 2. Well, it gives you a radius of 4. So our area in this case is going to be pi times 4 squared over 2, which is going to be 16 pi over 2. And that would be your answer, unless you want to simplify 16 over 2 and just make it 8 pi. Either one of these forms should be a sufficient answer here. So that's it. Then we have, I think this is the last one. Determine the point, if any, where the graph of the function has a horizontal tangent line. And so to do that, we set the derivative equal to 0, but let's find the derivative first. We get f prime of x is equal to 2x plus 2. And if we set that equal to 0, we get 0 equals 2x plus 2. So we get 2x is equal to negative 2. So dividing by 2x is equal to negative 1. So our point says find the point. Now you don't have a point without a y coordinate. So we got to go take this negative 1 back here. F of negative 1 is equal to negative 1 squared plus 2 times negative 1 minus 3, which is going to equal to 1 minus 2 minus 3. So f of negative 1 equals negative 4. So our points is negative 1 comma negative 4, and that's it. So that's a test, not a long test, but quite representative of the things that we've gone over. Good luck, learn, as always, and thanks for viewing.